Okay. Is it fine? TP? Okay, good. Now, next thing is, let's see how FP is calculated. Okay, so FP, so we have looked at TP, let's look at FP. It will be easier to calculate FP first and then we'll go to next discussion. So FP, so TP is 20, we've already got. Okay. Okay, now there's a question in cluster 3, why we are considering X instead of diamond? No, you are considering all the pairs, all the similar pairs. It doesn't matter which class they belong to, as long as they are from the same class, we consider that as a pair. Okay, so how many pairs are there? So that how many pairs are there so that each element in the pair belongs to the same class. Okay, to put it simply, how many pairs are there that each element in the pair belongs to the same class? Okay. Okay, now there's a question, but for purity we need to measure X only. The purity was different. Now we are considering rand index. Okay, forget about purity now. This is not relation to purity. Now you are calculating rand index. Okay, and these are definitions. So you look at pairwise. So it is different from whatever you studied earlier. Okay, so in purity you only looked at majority element, but here you're looking at pairs. Okay, so in cluster 3, I'll repeat again. In cluster 3, for calculating PP, in cluster 3, how many pairs can you make which are similar? Okay, so that means here you have, because we have more than one axis, there are two axes, and you can form pairs from this. Of course, there is only one pair that is possible out of X, which is contains same item, and out of 3 diamonds, you can calculate 3C2, that is 3 pairs. 3 pairs of similar items. So 3 pairs of similar items with diamond and 1 pair with X. So total 4. In other earlier cases, apart from the majority, there was no other pair possible. If you look at here, in XL, in the cluster 1 and cluster 2, there was no other pair possible. So they didn't create. But here, apart from in cluster 3, apart from the majority that is diamond, there was one more pair possible with X. So you create one more pair with X. Okay, so it doesn't matter whether it is majority or minority, as long as you can form a pair with 2 elements, so that 2 elements belong to the same class, not cluster. Okay, so here X belongs to the same class in cluster 3. Okay, now let's look at FP. So FP is the number of dissimilar pairs to the same cluster. Okay, so again this one is easy to calculate because we are looking at cluster by cluster again. Okay, so FP will be the number of dissimilar pairs but which are in the same cluster. So you have to again look at cluster by cluster. Same cluster means cluster 1 and cluster 2 and cluster 3. So let's look at cluster 1 first. Number of dissimilar pairs which belong to cluster 1. How many such dissimilar pairs are possible in cluster 1? Dissimilar pair means the 2 items that don't belong to the same class, then they are dissimilar. Similar means in the pair, similar pair means both items in the pair belong to the same class. That is, both are X or both are O or both are diamond. In case of dissimilar, they are not same. They are from different class. Okay. So how many pairs are possible in cluster 1 which are from dissimilar class? Zero. No, not correct. 1 is also not correct. So I can see like, let's see this pair. This doesn't. This is a similar pair, right? There is one more pair that is similar. We have one more pair that is similar. So many pairs are there which are dissimilar. So you can see that for if you just combine this O, the circle, with any of the cross, you get a dissimilar pair, right? So that means there are a total of 5 dissimilar pairs possible. In cluster 1. So cluster 1 has 5 dissimilar pairs. In cluster 2, how many dissimilar pairs are there? Okay, these pairs, remember, they are unordered. Okay. In cluster 2, how many dissimilar pairs are there? So if you look at X, you can create 5 dissimilar pairs with that in cluster 2. Look at X, you can create 5 dissimilar pairs with any other example in cluster 2. Is a dissimilar pair with X. So 5 with X. Then with diamond, you can create 5 or 4 more, right? So 9 total. So 5 plus 4 is 9. So 9 dissimilar pairs are there in cluster 2. So many of you have said 9, that is correct. Okay. So some of you are saying 10. 10 is not correct. Maybe you are calculating X and diamond 2 times. Okay. So this X and diamond as a pair, maybe you are calculating twice. So this pair is unordered. Okay. So X diamond or diamond X in this pair, they mean the same thing. Okay. So 9 is the answer. In cluster 3, how many dissimilar pairs are there in cluster 3? So with the first X here, you can create 3 dissimilar pairs, and with the second X also you can create 3. So total 6 dissimilar pairs are there. Right? So totally, how many dissimilar pairs you have got? 1, 2. So total first cluster you got 5. In the second you got 9, right? So we sum them up. 5 plus 9 plus 6, again you got 20. So FP is also 20. So you can see that TP and FP both are 20. TP you calculated earlier was 20, and FP is also 20. Okay, someone is asking how 6? Let me repeat again. So for the first X, for this example, which belong to class X, you can create how many dissimilar pairs? You can create 3 dissimilar pairs with diamond. Okay, and with this example is again belong to the category X, class X. You can create 3 more. So total 3 plus 3, 6. So total 6 pairs are there, which can be which are contributing towards the FP. Okay, or these pairs are dissimilar pairs. Okay, is it clear? Any questions? Okay, there is a question. XD and again XD, they are same. No, they are not same. If the examples are different, they are different. Okay, they are all different examples. Remember. Okay, it is not the same example. It's different example. X is only representing the label, actual label of that. Okay, so dissimilar pair here is those pairs which are from the different labels. Okay, so for example, these 2 examples, they belong to different labels, so that is one pair. Okay, similarly, so this is one pair, second pair, third pair, okay, fourth pair, fifth pair, and sixth pair. So total 6. So each cross or O is a separate example. Okay, don't think that they are duplicates of each other. They are not duplicates. They are different examples. Okay, X and O's are just labels. Okay, how in cluster 2 you got 9? Yeah, in cluster 2 we got 9. Right. So in cluster 2, look at the how many pairs you can make it with this X. 5 pairs, 5 dissimilar pairs you can make with this X, right? So 5 dissimilar pairs you can make this with this X. Okay, or with this particular example X, this label X. And then how many dissimilar pairs can you make with any of the O's that you have not already calculated with X? So that is 4 more, right? So 5 plus 4 is 9. Okay, so 5 with X. Okay, and you can say 4 with diamond. That's fine. Okay, so 5 with X and 4 with diamond. What you can do is you can just look at each pair as a line. Okay, so each line going from one to other is a one pair. You cannot make, you can count it twice. That's all. So 5 pairs from X, and then 4 more pairs from with diamond. Let's say one pair is here, the other is here, 2 and 3 and 4 more pairs. So 4 more pairs with this diamond. So 5 plus 4 is 9. Okay, so that's clear. Now let's come to true negative. Okay, so true negative means so here negative, remember to understand this, true means correct, okay, correctly, and negative means they are different clusters. Okay, so the second part is negative or positive. Positive means in the same cluster, negative means in different cluster. True means correctly, and means different clusters. Okay, so how many pairs are there, okay, which are correctly put in different clusters? So when 2 pairs are correctly put in different clusters, that means they must belong to different class. Okay, so now you look at pairwise clusters, pairwise, so that each pair is dissimilar. Okay, each pair has dissimilar label, and they belong to different cluster. Now instead of looking at an individual cluster, you look at pairwise. So look at cluster 1 and cluster 2. So this is a little more difficult to calculate. Okay, and it will be a large number. So if you look at, let's say X, okay, X in first cluster, any X, let's say one first X we are taking here. Okay, so how many dissimilar how many dissimilar pairs can you create with this X, and so that second element is from cluster 2. So you're going to take X because they are two different, but you can take any of these 5 other examples with this X, so they will be dissimilar, right? And same thing can do with any other X, right? So 5 with one X, and there are a total of 5 X in the first cluster. So 5 into 5 is 25. So you can make 25 dissimilar pairs with X's. Okay. Then how many dissimilar pairs can you make out of other than X? There is only O in the first cluster. So out of this O, how many dissimilar pairs can you make with respect to cluster 2? Only 2, right? So are you getting it? So 25 plus 2, that is 27. So just remember this 27 is the number of dissimilar pairs that you made between cluster 1 and cluster 2. Okay. Now let's look at cluster 1 and cluster 3. So how many dissimilar pairs can you make out of made from, let's say, any x from cluster 1? Let's look at cluster 1 and cluster 3 now. Okay. So maybe I'll just clear everything. Just write 27 for cluster 1 and cluster 2. That we have already calculated. Now we are looking at, let's take this x, and how many dissimilar pairs can you make out from cluster 3? Taking another element from cluster 3 with one x, you can create 3 dissimilar pairs. So you have 5 x's, so you can create 15 dissimilar pairs, so that x is from cluster 1 and this diamond is from cluster 3. Okay. Now, apart from this, you can also form some dissimilar pairs with O from cluster 1. Right? If O is from cluster 1 and x is from cluster 3, then also you can form dissimilar pairs. So there are 2 such pairs. It's 15 plus 2. Okay, sorry, no. So there's diamond. This third one is diamond. Okay. So with respect to O, so first cluster has O. The third cluster has only diamonds, no O. So that means all 5s are available. So 15 plus 5. So there are total 20 dissimilar pairs you can form from cluster 1 and cluster 3. Okay. So 15 were when x from cluster 1 and diamond from cluster 3, and 5 are when O is from cluster 1 and any other element from cluster 3, diamond or x, they are all dissimilar. So with cluster 2 and cluster 3 it is 20. Okay. So which other cluster pair remains? There's cluster 2 and cluster 3 that you also count. You have to count, right? So let me just clear them all. Like 27 and 20. Now consider these 2 pairs, cluster 2 and cluster 3, and see how many dissimilar pairs you can create so that one element is from cluster 3 and the other element or the pair is from cluster 3, cluster 2 and cluster 3. So if you look at x, you can create 3 pairs with diamonds of the 3 diamonds of the third cluster. Plus, if you look at the 4 circles, right, then you can take any of the 5 elements. So 4 into 5, so 20 such pairs will be created. Okay, and there's one diamond in the second cluster, and that can form a pair, a dissimilar pair with any other 2 axes, right? Cannot, because other 3 are diamonds. So plus 2. So that is 25. Total 25. So 25 here. Okay. So total, so the sum, if you sum of them all, you get the true negative. So that is sum them up, 12 and 72 is the true negative. Okay. So you have calculated TP, you have calculated TN, and you have calculated FP. You have calculated or not? FP also we have calculated. Yes. So TP and FP were both 2020, right? TN has come out to be 72. The only thing remaining here is FN, false negative. False negative means incorrectly put in different clusters. That means they are same, but they are put in different clusters. Okay, but as it comes, once you calculate 3 of them, you don't need to create to calculate the 4th, because you will get immediately from NC2. So we have calculated earlier that there are 136 pairs possible, and we have got this many pairs, 72 plus 20 plus 20, right? TP plus FP and TN are given. So only thing remains is FN. So FN should be equal to 136 minus whatever you have calculated. There is no other pair possible. So 136 is the total pairs possible. Okay. Subtract the TP and then subtract FP and subtract TN. That is 72. So this will give you FN. So 40 plus 72, 112. So get some answer here. 75 or something. So provided you have calculated everything correctly, the formula for the RAND index is TP plus TN divided by the total. Okay. So as it comes out, you don't have to calculate the or compute individual elements of the denominator, but you have to calculate TP and TN. If you get TP and TN correctly, the denominator is nothing but NC2. Okay. So denominator here is nothing but NC2, N choose 2. In this case, it is 136. So TP and TN are correctly calculated, then our other thing is fine. So TP was 20 and TN was 72, I think, that we calculated. If it is correctly calculated, it was 20 plus 72 divided by 136. That is our RAND index. 92 by 136. So let us look at the actual answers. Yeah, so they are correct. Okay. So these are the pairs. They are same class and same cluster. It is TP. Okay. Same class but different cluster. It is false negative. Okay. If it is different class, put in the same cluster, it is false positive. So TP and FP are both 2020. False negative is 24. If they are different class and different clusters, that is true negative. That is 72. We calculated it, and RAND index is now I got 0.68. Oh. Okay, so RAND index is equal to 0.68 that you get. The higher it is, the better. Okay, so higher it is means the numerator will be higher. That is TP and TN will be higher. That is the correctly labeled positive and negative approximation will be high. Okay. So it's a measure of goodness of cluster. Yes, it's one of the external measures. Okay, but there are certain drawbacks of this, and so there are improvements on this called ARI, that adjusted RAND index. There is something called mutual information based. So in clustering, there are a lot of metrics available. Okay, because no one metric satisfies all in this case. In case of clustering, in case of classification, it is easy. You have precision, you have recall, you have F score. So I think it's fine for all. But in case of clustering, because you don't know the actual labels beforehand, and then you actually look at the actual level measure, map them up, and then come up with some measure, some external measure. Okay, and the number of clusters also, it is not, many times it is not available. Okay, so number of clusters may be also decided by the algorithm itself. So what we have studied so far is k-means and hierarchical clustering, where k is fixed, number of clusters is fixed. Okay, but in many algorithms, the number of clusters is even not fixed. Okay, so how many clusters is created depends upon the clustering algorithm. Okay, so that's why there are a lot of different external evaluation metrics for clustering. Okay, so anytime, anywhere clustering is used, RI can be used, RAND index can be used. Okay, but there are adjusted RAND index, other advanced mechanisms which have taken over. But this is the basic, so you should remember this. Okay. So where RI is used practically, any application that any clustering application, anywhere you want to measure the goodness of clustering. There is no specific use case, anywhere you can use. Okay, all right. So we have some more time. Okay, there's question. C1, C2, C2, C3, and C1, C3 for different cluster calculation. Yes. Okay, so all the pairs of clusters will be used to calculate true negative TN. Right? True negative means correctly in different clusters. So you'll need all the different pairs. We have to calculate different cluster, different pair. That is different thing. That is false negative. That is true negative. That's fine. Okay. Different cluster, different pair. Yeah, that's fine. True negative. Okay. Please open one of the file from the data set and explain. We want to export that on assignment. Till we get the data frame from the mail data, definitely need your help. Please take one file and explain. So okay. On data preparation, till we get the data frame. No, see, all these things have been explained earlier. Okay, how to take file, how to vectorize a file, all these are explained in one of the classes. So don't worry about this, you can do it easily. Okay, and count vectorizer, you can actually give a list of files, name of the files, and it will automatically do it for you. Okay. So email consists. Okay, so how to convert email to a data frame? So email contains words. Remember, every email has words. Okay. So what you do here in the emails is, so each word, okay, each email is a document. Okay, and there are say 250 documents in the clustering example. Okay, so 250 documents or 250 emails are there. Okay, so each word will be present multiple times. Okay, so you just have to calculate, just have to call count vectorizer on each file. That will automatically calculate calculate the vocabulary for you, create the vocabulary for you, and the count of each word in the vocabulary for particular documents. It will create a term document matrix for you. Once it is formed, just train and test for classification, and for clustering, just cluster. Okay, but before that, you open the file, open each of the files. Let's say there are 250 files for clustering or for classification. Open each file. Okay, apply Porter stemming. Okay, apply stemming. That is Porter stemmer is available in Analytica. Look at some online help. You'll get it easily. You just have to call function. Okay, so apply the Porter stemmer and then save those files. So for 250 original files, after applying Porter stemmer, new files will be created. Okay, so those files will be stemmed, will contain a stemmed word. Each word is stemmed. Stemmed means basically the suffixes are removed. Some of the suffixes which are not required are normally removed. Okay, for example, organization. So TION is removed. Only the first initial important part remains there. Okay, so save the stemmed version as new files, and then apply or call the count vectorizer or TF-IDF vectorizer on that stemmed version. Okay, and then these TF-IDF vectorizer as well as count vectorizer, they take arguments called stop words Okay, you can say yes. It also takes argument like min df. You can give 2 or 3 or 4, whatever you wish. That is minimum number of document a word must be present so that it is considered. Otherwise, it is not considered as part of the vocabulary. It is ignored. Okay, so the Porter stemmer is available in NLTK. Okay, NLTK library. Natural Language Toolkit. So import NLTK and just read online how to use the Porter stemmer. That's only 2 lines of code that you need to add. Okay, so NLTK is the library that we'll be using for Porter stemmer. So it will stem each of the word to its prefix. It will remove the suffix, unimportant suffix. Okay, so read about stemming yourself. And once you have done, so remember that only part that you'll need to learn here is the pre-processing part. Okay, after that everything we have done in the class here. The classification we have done clustering, so that will be easy for you. Okay, the only part that we to do involve a bit of time is the pre-processing. Okay, how to do stemming, and then how to save file, and then again read those files. That's all. Yeah. So there's a question for assignment to summarize for data preparation. Use techniques like stop words. Okay. So remember that all these things are available in count vector. Stop words removal, punctuation removal, and TF-IDF, DF min DF. They are all available in sklearn. When you call the function itself, it will do it for you. Only thing that is extra that you will need to do is the stemming part. Okay, stemming you have to perform before calling count vectorizer or before calling TF-IDF vectorizer in sklearn. Okay, stemming is a pre-processing step before that you have to do. Yes, so pre-processing means the Porter stemmer that you do before on the email dataset. Okay, and then save that stemmed files instead of original files. You'll be now working only on the stemmed version of the files. Then you'll apply the classification APIs which are available in sklearn or clustering APIs on those stemmed versions. Okay. Right. So rather than calling count vectorizer, I suggest you use TF-IDF vectorizer, TF-IDF. Okay, because that will provide better weights. TF-IDF vectorizer. Okay, and when you call TF-IDF vectorizer, you have options like stop words, removal. You have option like min df that will tell it how many documents a word must be present in to consider it for vocabulary. Otherwise, if it's present in say 2 or 3 documents, you can set min df is equal to 2 or 3, and below that any word which is present in say 1 or 2 documents will not be considered. Yes, that is correct. Okay, so pre-processing, save the stemmed version, call TF-IDF vectorizer or TF-IDF transformer, whatever you wish, and then after that it is tenfold cross validation in case of classification, or the clustering in case of hierarchical clustering or k-means clustering. Once it is done, just and even this silhouette and all, we have already explained in the class how it is calculated in sklearn. You can just call those. Yes. Okay. Yes. Try for number of clusters and see which is giving the best result. Okay. Because I am not for clustering problem. I have not told you how many clusters are available, how many clusters are there. Okay. So you have to experiment with number of clusters from 1 onwards, 1, 2, 3, 4, or from 2 onwards, 2, 3, 4 onwards, and see which is giving the best result in terms of the silhouette coefficient. And finally, once you have got the best results, give the output of the program and give the Python file as a single zipped folder. Okay, clear? All right. No, don't worry about elbow point and all. Okay, just look at which is giving best result, best score, silhouette score. Okay, so we have not discussed about elbow and others, so don't worry about it. Look at which is giving you the best score. Or if you wish, if you are comfortable with elbow point, you use it. Okay, it's up to you. Okay, so we will stop here today, and in the next session we will carry on from here. Okay, so look at some of the issues with the classification. Basically, that is overfitting and all. And we'll also look at the ensemble classifiers, how they work, ensembles of classifiers. All right. So if you have any doubt, any questions, please send them to the forum. Okay, post them in the forum, and I will reply there. Okay.